Hello, a very good morning to everyone and welcome to this course Physics 1. This course is generally made for undergraduate level BTech degree students. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baripur. Also, the subject teacher for this course. You can meet me personally at college premises, ground floor physics lab. You can also send me mail regarding your doubt or query related to this topic at the given mail address, that is godphysics6@gmail.com and gopal.chakraborty_gkcem@gisgroup.org. You can also subscribe my YouTube channel for more educational videos. So for this topic, the course pages are www.markoutexam.net or www.markoutwb.ac.in. You can also find the syllabus for this course is already uploaded in the university website. The title of this course is Physics 1. The subject code is BSPH101. It is under the category of Basic Science course. It has a credit 4 and 3 lectures per week and 1 tutorial per week. So this course is generally made for BTech degree students of first year. So after passing out from 10+2 level, students have to study this course. So computer science, civil and mechanical, these departmental students will going to study this course for their odd semester, and alternatively electrical and electronics departmental students will going to study this course for their even semester. Now, today the topic I will going to cover derivation of Maxwell's equation, wave equation for charge-free space, velocity of electromagnetic wave in free medium. So these topics is actually under the module 3, that is electromagnetism and dielectrics, magnetic properties of material. So prerequisite for this course: elementary idea of electrostatics and dielectrics and fundamental idea of vector calculus. The course objectives is idea about electromagnetic theory, know to derive each Maxwell's equation. So after completion of this course, students will able to know the characteristic of electromagnetic wave equation. They will also able to derive each Maxwell's equations and its application. They will also able to calculate the velocity of electromagnetic wave. So these are the possible course outcome. In my first video of Maxwell's equation from electromagnetic theory, I have discussed about what is electromagnetic wave and what are the Maxwell's equation for different cases. So there I have already told you that time varying electric field, that means oscillating electric field, will generate oscillating magnetic field and vice versa. So the vibration of electric field and magnetic field constitute a wave that is called electromagnetic wave. So each electromagnetic wave must follow these four Maxwell's equations. And what are the Maxwell's equation? The first one is del dot E equals to rho by epsilon naught, or del dot D equals to rho. The second one is del dot B equals to 0, or del dot H equals to 0. The third one, that is del cross E equals to minus of del B del T, or minus of mu naught del H del T. And the fourth equation, that is del cross H equals to J plus del D del T equals to sigma E plus epsilon naught del E del T. So these are the four Maxwell's equations. I have already explained what are the corresponding physical significance of these four Maxwell's equations. The first one actually represents the Gauss's law for electrostatics, whereas the second one is Gauss's law for magnetostatics. Third one is the representation of Faraday's laws of electromagnetic induction. And the fourth one is modified form of Ampere's law. So if you missed out that video, I suggest please go through that video, previous one, the first one of Maxwell's equation, because when you are going to derive these four Maxwell's equations, you need to know what are that equations and what are the physical significance of these equations. So this is also as a prerequisite to understand today's class. So please go through the video once again and continue with the today's class. Now I will explain how you will going to derive each Maxwell's equation step by step. Now came to the first Maxwell's equation, that is del dot E equals to rho by epsilon naught. So before going to derive this equation, what is the meaning of this expression? The meaning of this expression actually it states the Gauss's law for electrostatics. So which law states that the total normal electric flux through a closed surface is equals to 1 by epsilon times total charge enclosed by the surface. And it is clearly visible to you that this first Maxwell's equation is a time independent equation. So this equation also states you that electric lines of force is not a closed curve. It will generate from the positive charge. So the origin are at a positive charge and ends at a negative charge. Now with this concept, I will going to derive the first Maxwell's equation. So you can see the derivation is given there. Now I will explain. So as per Gauss's law, it is considered that total normal flux, which is represented by phi, that is equals to Q by epsilon naught, where Q is the total charge enclosed by the surface and epsilon naught is the permittivity for free space, which has a value 8.854 into 10 to the power minus 12 Farad per meter. So also the flux can be represented as surface integral E dot dA, where dA is the surface. So comparing equation 1 and equation 2, you can substitute that integration of E dot dA, that is equals to 1 by epsilon naught volume integral rho into dv. So how you will find that right hand side is the integration of rho dv. As you know, the charge density rho, that is equals to charge per unit volume. So here the integration of dv, that will give you the total volume. So that means charge density into volume, that will give you the total charge enclosed by the surface. So I have substitute that value and get integration of E dot dA, that is equals to 1 by epsilon naught volume integral rho into dV. Now applying Gauss divergence theorem in the left hand side, which relates actually the surface integral with the volume integral. I have explained this Gauss divergence theorem and its application in my video lesson of vector calculus. So you can check that video. So here I have directly applied the Gauss divergence theorem in the left hand side. So after application of this theorem, I will get volume integral del dot E dV, that is equals to 1 by epsilon naught volume integral rho dV. So now you can take all the term in the left hand side and you can take common, so you will get the volume integration within bracket del dot E minus rho by epsilon naught dV, that is equals to 0. Now that volume integration of dV, that can't be 0 because volume may be infinitesimally small, but it can't be 0. It has a value. It may be negligible, but it can't be 0. So to satisfy this expression, rest of the part must be equals to 0. So rest of the part must be equals to 0 means del dot E minus rho by epsilon naught, that will be equals to 0. So from there we get del dot E equals to rho by epsilon naught. So where E is the electric field, rho is the charge density, and epsilon naught is the permittivity for free space. So by this way you can derive the first Maxwell's equation, which states Gauss's law for electrostatics. Now the second Maxwell's equation, that is del dot B equals to 0 or del dot H equals to 0, where B represents the magnetic field induction and H represents the magnetic field intensity. So before going to derive this equation, again I will explain what is the meaning or physical significance of this expression. So it is very clear to you, this equation actually tells you the Gauss's law for magnetostatics, which states the flux, magnetic flux around a closed curve or closed surface, that is equals to 0. So it is also a time independent equation. So this equation also states that magnetic lines of force is a closed curve. It originates from the North Pole and ends at South Pole, which means isolated poles or magnetic monopole doesn't exist. It exists always in a pair. So considering this concept, now I am going to derive the second Maxwell's equation, that is del dot B equals to 0. So as I have told you that Gauss's law for magnetism states that the net flux of magnetic field through a closed surface is 0, because monopoles of magnet do not exist. So from that concept we can write surface integral B dot dA, that is equals to 0. So it is the integral form of Maxwell's second equation. Now if we apply again the Gauss divergence theorem, which relates the surface integral to volume integral, so left hand side that part convert into volume integral, and you will get volume integral del dot B dV equals to 0. So in right hand side it will be 0. So this implies that integration of dV, that means volume integration, volume may be infinitesimally small, but that can't be 0. So as it is not 0, so to satisfy this equation the rest of the part must be 0. So rest of the part is 0, it means del dot B, that is equals to 0. So this is called the differential form of Maxwell's second equation. So that idea and concept is very important because this expression actually tells you isolated magnetic poles or magnetic monopoles doesn't exist. So that's why if you divide a bar magnet in number of times, you will always find a north pole and a south pole. So here I have shown you a diagram where the lines of force is originating from north pole and ending at south pole. So you can divide, you can break up this bar magnet in a number of parts. So each part will give you north pole and south pole. Now the third Maxwell's equation, which actually tells you the Faraday's laws of electromagnetic induction, that is del cross E equals to minus of del B del T. If you substitute the value of B, you will get del cross E equals to minus of mu naught del H del T. So this equation actually a time dependent one. So it tells you the change in magnetic flux will help to produce an induced EMF in that circuit. So from this equation you can see how the induced EMF will generate when you change the number of lines of force perpendicular through per unit area, that means magnetic flux. So alternative magnetic, as I say that alternatively this equation will also tells you that negative sign is there, that means that induced EMF will produce that as the direction of it will oppose the actual cause of it, which is proofs of the Lenz's law. Okay, so considering this all of concept, now I will going to derive the third Maxwell's equation. Now we can consider as per Faraday's laws of electromagnetic induction, that is E equals to minus of n d phi dt. So since EMF is related to the electric field by the relation E equals to integration of E dot dA, also the magnetic flux, that is equals to a surface integral B dot dA. So put these values in equation 5. We get the surface integral E dot dA, that is equals to minus of n surface integral of B dot dA. So for n equals to 1, we have integration E dot dA, that is equals to d dt of integration B dot dA. Now it is the integral form of Maxwell's third equation. So applying Stokes' theorem on the left hand side, Stokes' theorem, this part I have discussed in my chapter vector calculus, so you can check that video. So here I have directly applied the Stokes' theorem in the left hand side, which relates the surface integral to a line integral. So this actually convert surface integral del cross E dA, that is equals to d dt of surface integral B dot dA. So surface integral del cross E of dA plus d dt of integration B dot dA, that is equals to 0. So as the surface may be infinitesimally small but it can't be 0, so we can write del cross E plus dB dt equals to 0 to satisfy the above equation. So ultimately we'll get del cross E equals to minus of del B del T, so which is our third Maxwell's equation. So a diagram is given here. You can see that we have considered two coils. One coil is connected through a battery EMF. So if you change magnetic flux, that means lines of force, for one coil, subsequently the alternate coil will produce induced EMF, that means current, which shows the deflection in ammeter. So this is proof the third Maxwell's equation. Now the fourth Maxwell's equation. So this one is the most important one for your semester exam, because if you check last 5 years or 10 years question, you may find lots of question will be there regarding the derivation or the physical significance of this fourth Maxwell's equation in your question paper. So before going to derive this fourth Maxwell's equation, I will tell you what is the meaning of this equation. So as we know, the fourth Maxwell's equation is del cross H equals to J plus del D del T. So J is the conduction current density, which has a value sigma E, and del E del T, that is the displacement current density. D equals to epsilon naught E, so that value will be equals to epsilon naught del E del T. So that means the del cross H, that will be the sum of the total current density, that means current density for conduction and current density for displacement. So this is very important because this equation includes another term that is called displacement current density, which actually makes the current continuous through the conductor. So now I will going to derive the Ampere's law, modified form of Ampere's law, which is fourth Maxwell's equation. So it means in case of Ampere's law, general form of Ampere's law, some deficit is there. That means this law is valid only for a particular case. For general case, you can't apply the Ampere's law. So you can apply the Ampere's law only for steady state condition. So you have to know what are the general expression about modified form of Ampere's expression, because the Ampere's law need to be modified to make it general, to make it apply to the each and every case for the time varying field also. So now I will show you what are the deficit of the Max Ampere's law and how you will modify that expression to find out fourth Maxwell's equation. So the the differential form of Ampere's law is del cross B equals to mu naught J. So as you put B equals to mu naught H, so mu naught will cancel out and we will get del cross H equals to J. So taking divergence on both sides, we will get del cross H, that is equals to del dot J. So as del cross H equals to H dot del cross del, considering the formula A dot B cross C equals to B dot C cross A or C dot A cross B, so we get del cross del equals to 0, so which gives us that del dot J equals to 0. So substituting this value, we get del dot J, that is equals to del cross H dot with del, that means H dot del cross del, that will be equals to 0. So ultimately from equation 2 we get del dot J equals to 0. Now as we know, the equation of continuity is del dot J plus del rho del T equals to 0. So if you substitute del dot J equals to 0, that gives us del rho del T equals to 0. So that means rho will be constant. So rho is constant of time, which is the characteristic of steady current in the conductor. So equation 1, Ampere's law, is incomplete for time varying current. To make it complete, for both cases, displacement current density is to be added with the conduction current density. So we can write from the equation of continuity that del dot J equals to minus of del rho del T. So putting the value of first Maxwell's equation, we get del dot D equals to rho, so we substitute the value of rho, and ultimately we get minus of del dot del D del T. So taking common, we get del dot within bracket J plus del D del T, that is equals to 0, which is within bracket term that is called J effective. So the total current density. So instead of Ampere's law, that is del cross H equals to J, you can put J effective. So del cross H equals to J effective, that is equals to J plus del D del T. Now it is a complete form of modified Ampere's law and the fourth Maxwell's equation. Okay, so this part is complete. I have derived all the 4 Maxwell's equations step by step. Now I will going to derive the wave equation for free space, charge free space. So wave equation means the equation for electric field as well as for magnetic field. So before that, for charge free space, you have to know what is your Maxwell's equation first. Then I will show you the procedure how we are going to derive the wave equation. So these are the Maxwell's equation for free space or in vacuum, that is del dot E equals to 0 or del dot D equals to 0. Del dot B equals to 0 or del dot H equals to 0. Third one, del cross E equals to minus of del B del T or minus of mu naught del H del T. And fourth equation, del cross H equals to del D del T, because as it is a free space, so charge density or conductivity all goes to 0. So conduction current density will also 0. So now I will show you how to derive the wave equation for free space. So now you need to know what is the procedure. You don't try to remember all these things, okay? You just try to understand how you will derive or how you solve this kind of derivation. So the basic procedure is both the wave equation for electric field and magnetic field are almost same. So you don't need to derive the both two. You can derive first one electric field or for magnetic field. So simultaneously you can write that. Similarly, the wave equation for the alternative one will be this. Okay. So the basic concept is if you are going to derive the wave equation for electric field, you have to start with the equation 3, that is del cross E equals to minus of del B del T, and then you have to substitute the value of the B or H from the fourth equation in the third equation. Okay, so you just taking curl on both sides of the third equation. After taking curl, you will get solving some value. In the right hand side, you have to substitute the value from equation 4, the value of H del cross H, then that will give you the wave equation for electric field. Similarly, if you are going to find out the wave equation for H magnetic field, so you have to start with the equation 4. You have to take the curl of equation Maxwell's equation 4, and then you have to substitute the value of del cross E from the third equation. So this is the procedure. I will show you step by step how I am going to derive this. So as I have told you, we have taken curl of the third Maxwell's equation that gives us del cross of del cross E equals to minus of del T of del cross B, or minus mu naught del T of del cross H. Now from fourth equation I have substituted the value, and in the left hand side what I will get, del of del dot E minus of del square or grad square E. So now as from the first equation del dot E is already 0, so from the left hand side we get minus of del square E equals to minus of mu naught del T of del D del T. So if you substitute the value of D, you will get epsilon naught del E del T. So both sides, the negative sign we will cancel out, and we get del 2E equals to mu naught epsilon naught del 2E del T2. So del 2E del T2 equals to V square grad square E. So this is the wave equation for charge free space and for electric field. So similarly you can also write the wave equation for magnetic field for charge free space is del square H, that is equals to mu naught epsilon naught del 2H del T squared. Now, from this equation you can also able to find out the velocity of electromagnetic wave in free space. So, you know the wave equation for electric field and magnetic field vectors are del 2E minus mu naught epsilon naught del 2E del T2 equals to 0. Similarly for magnetic field it is del 2H minus mu naught epsilon naught del 2H del T2 equals to 0. Now the three-dimensional wave equations without damping and traveling with velocity v can be written as del 2 psi minus 1 by v square del 2 psi del t square equals to 0. So hence comparing these two equations, what we will get? We get the value of v, that is equals to under root 1 by under root mu naught epsilon naught, where mu naught is the permeability for free space, has a value 4 pi 10 to the power minus 7, and epsilon naught, that is permittivity for free space, has a value 8.854 into 10 to the power minus 12. So if you substitute this value, what you will get? The value of v will be almost equal, approximate, that is 3 into 10 to the power 8 meter per second. So what we see that the velocity is almost similar to the velocity of light for free space. So we can say that electromagnetic wave travels in the speed of light in a charge free space. So this is the expression or equation for velocity of electromagnetic wave in free space. Now another important derivation, that electric field vector and magnetic field vector are perpendicular to each other? This is a very important question. I will show you how we are going to derive or to prove this. So the plane wave equations are del 2E equals to mu naught epsilon naught del 2E del T2 and grad square V equals to mu naught epsilon naught del 2B del T square. So these are the plane wave equation for electric and magnetic field vector. So now what are the solution of this equation? The solution can be considered as E equals to E naught exponential I k dot x minus I omega t, and B is equals to B naught exponential of I k dot x minus of I omega t plus phi. So here, by including the phase constant phi in the expression for B, we allow for a possible phase shift between E and B. So inserting this expression into Maxwell's equation, we have del dot E equals to 0, so therefore k dot E naught equals to 0, or del dot B equals to 0, therefore k dot B naught equals to 0. Thus both E and B are perpendicular to the direction of propagation. From Faraday's law we can write k cross E naught exponential of I k dot x minus I omega t equals to omega B naught exponential of I k dot x minus I omega t plus phi. Since the relation must be true for all x and t and k is real, so we have phi equals to 0. So E and B oscillate in a phase, and B naught, that is equals to k by omega into E naught, that is equals to 1 by V k cap cross E naught. So B is also perpendicular to E, and which has a magnitude E by V. So this actually proves that electric field and magnetic field vector are perpendicular to each other. These are the reference book that you may consider for as a reference book. So you have a same evaluation process, that is same exam, external exam for 70 marks and internal exam for 30 marks. Hope all of you have understand today's class, and in next class I will going to complete this chapter, that means Maxwell's equation from the electromagnetic theory. So thank you.